Polynomials. A polynomial in one variable, let's say x, is just an algebraic expression that can be written in the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 2 x squared plus a1 x plus a naught. Well, where n is in a negative integer and all these a's are numbers, real numbers that are known. They're not variables. They're numbers that we actually know. And the numbers a's, the a sub n's, are called the coefficients of the polynomial. This polynomial is in descending order. So, I mean, one example, let's say, of a polynomial would be something like 5x to the 4 plus 3x squared plus 4x plus 1, right? We usually write them in descending order from the exponents of the variable. So that's an example. And the highest exponent that you see is called the degree of the polynomial. So this one right here would have degree 4. And it has 4 terms. I mean, that's a coincidence. So the degree is 4 and it has 4 terms. 1, that would be 1, 2, 3, 4. So the terms are separated by either pluses or minuses. So there's 3 pluses and you have 4 terms. This one right here, that is called the leading term. Okay, so it is the whole thing, the 5, the x, and the 4, so it includes the whole thing. That would be called the leading term. And the very last one, the one that does not have x, in this case this one, that's called the constant term. Okay, and the 5 in the leading term, in this example, is called the leading coefficient. So the number that is in front of the leading term, the coefficient in front of the leading term, is called the leading coefficient. Okay, so one condition for something to be able to be classified as a polynomial is that the exponents of the variables all have to be integers. Positive, actually, positive integers. So you cannot have as an exponent something that is a negative exponent. That is a no. It would not be a polynomial if you see that. Or if it has an exponent that is a rational number or a decimal, that is not a polynomial. So all the exponents for the variable x need to be positive integers. Okay? All right. Polynomials should always be completely simplified. And to emphasize what I just said, variables can only have positive integer exponents, and no variables should appear in denominators. Note that in the general expression for a polynomial, there's no fractions anywhere. If there are fractions, it has to be in the coefficients, in the a's. You cannot spot variables on the bottom. If you see that, that's not a polynomial. So you could have something like this just fine. 5 halves x squared plus 5x plus 7/3. That's a polynomial. But the variables cannot be on bottom. So if you have this, 2x plus 5x plus 7/3, that's not a polynomial because you see variables on the bottom. Okay, that's going to be called a rational expression. We'll discuss those later. Okay, so let's consider the following algebraic expressions and determine whether they are polynomials or not. And if it is a polynomial, then tell what is the degree, what is the leading term, and what is the leading coefficient. So the first one, what do you think? Is that a polynomial? Yes or no? Right? If you say yes, then that's correct. This one is a polynomial. It is a polynomial, and then the degree equals to the leading term would be x squared. You have to put it in order in order to figure out the leading term. The leading term is not necessarily the first one. Uh, is the first one is the first term if it is in descending order. If it is not in descending order, it's not going to be the first one. So in this case, it is in descending order, so the leading term is x squared, and then the leading coefficient is the number in front of the leading term. In this case, is a 1. There's an invisible 1. Remember that. Okay. All right. How about the next one? Do you think it is a polynomial? Yes or no? The answer to this one is a no. And that's because that term there ruins it. So decimals or fractions are not allowed as exponents. Are not allowed as exponents. Okay, how about the next one? Is that a polynomial? Yes or no? Okay, the next one is a polynomial. The degree, what is the degree? The degree is the highest exponent for the variables that you see. So actually the degree is 10. And the leading term is related to that degree, is a term that has that exponent 10. So that means the leading term is actually this one. You would normally have to put it in order to figure that out. If you put her in order, that's what that would be. So the leading term is 3x to the 10. And the leading coefficient will be the number in front of the leading term. So in this case, it's the 3. Okay, how about the next one? Is it a polynomial? Yes or no? X plus 2 over x. Okay, this one is a no. If that's what you said, then you got it right. This one is a no. That's not a polynomial because you cannot have variables in the denominator. Variables may not be in denominators. Okay? And that is actually like having that variable x in the denominator is pretty much like having a negative exponent because um, x plus 2 over x is actually the same thing, or can be rewritten as x plus 2x to the negative 1. Using the properties of exponents, that's the same thing. And we said that negative exponents are not allowed. So you see, that's a different way of looking at it. Uh, Either way, that's not a polynomial. Okay, and then the last one. Is that a polynomial, yes or no? X squared plus x to the 1/2. If you said no, then you are right. Fractions, decimals of fractions are not allowed as exponents for the variables. So, so the one term that ruins that is that one. That's not allowed. Okay, so it's the same explanation as this one. So I'm not gonna write it again. Okay, now let's talk about adding and subtracting polynomials. Adding and subtracting polynomials is actually really easy. So here, his example is you have this polynomial and that polynomial, and they're being added together. To add polynomials, all you have to do is really collect like terms. So you're going to collect like terms and so pair them up and add the coefficients in front of those like terms. So like terms the variables have to be identical. So x cubed and 6x cubed are like terms. Then, because the exponent is the same, 5x and this x right here are like terms. And then the constant, those are like terms. And then these, that one and that one don't have corresponding like terms. Okay, so now let's actually add the thing. So start by adding the ones that have the highest exponent first. So in that case, it would be this one. So that one doesn't get really combined with anything else. So 4x to the fourth. The cubic terms are that one and that one. So you have x cubed and 6x cubed. So that would be 7x cubed. You add the coefficients in the front, leave the exponent the same. Now the next term would be x squared. There's only that one. There's nothing to combine, so just x squared. Then the linear terms, which are linear. When I say linear term, that means a term that has exponent 1 for the x. So this one, 5x and x, so that would be 5 and 1x, that would be 6x. And then 1 and 1, that is 2. Okay, and that is it. So just combine like terms. That's all there is to that, adding polynomials. Okay, subtracting polynomials requires that we change the subtraction to a plus and then change the sign. So for example, this one, it says subtract these two polynomials. For this, we have to, this is the way to go. We're going to change that minus in there to a plus, and then when we do that, because this minus is in front of this parentheses, that means everything in that parentheses gets affected. So when we change the minus to a plus, everything in that parentheses is going to change signs. So this is going to be plus, and then this becomes negative 2x squared, negative x plus 2. So you see everything in that parentheses switch signs. So negative 2x squared minus x plus 2. And then now you add them as before. Collect like terms. So you have x squared and negative 2x squared. Those two are like terms. And then you have those two are like terms. And then the constant. Alright, so let's combine them. So x squared minus 2x squared, 1 minus 2, sorry, 1 plus negative 2 is negative 1. So negative 1x squared, or negative x squared. Negative 2x and negative x, we're adding negative 1, we're adding negative 2 and negative 1. Negative 2 and negative 1 is negative 3, so you could write plus negative 3. Next, and negative 2 plus 2 is 0. Okay, plus 0. We never write plus 0, okay? We don't do that. So we're going to actually write it as negative x squared, and then you can leave this as plus negative 3x, or you can just write minus 3x. Both are acceptable. this is what you would enter or offer as a final answer. Okay? All right. Now let's do one more, subtraction. You can pause the video. You should pause the video and try to do that on your own. See if you get the right answer. Okay, now let's do it. So I'm gonna leave the first one intact, and then I'm gonna change the minus to a plus, and I'm gonna change the sign of everything in that inside that parentheses. Minus 3x squared minus x minus 8, and then now let's combine like terms. X cubed, there's only this one, so it doesn't get combined with anything. Quadratic terms, quadratic means the terms that have a square as the exponent. So quadratic terms, you have minus 3x squared and negative 3x squared. So negative 3 and negative 3 does negative 6. So you could write plus negative 6x squared or just minus 6x squared. The linear terms, you have positive 1x and negative 1x. 1 and negative 1, that gives you 0. So plus 0x, but don't write plus 0x. And then negative 8 and negative 8, that's negative 16. Okay, that's it. Alright, so that's how you add and subtract polynomials. Now, let's talk about multiplying polynomials. Multiplying polynomials. Okay, we're going to do 4 examples. Multiplying polynomials. The first one is you multiply a monomial, polynomial has only one term, times a binomial. This one is just distribution. So to multiply these two, just distribute. Okay, so 3x times 2x squared, so you multiply the coefficients at 2 times 3 times 2 is 6, and x times x squared is x cubed, because you add the exponents. And then 3x times 5, that would be 15x. And that's all. Okay, now here's another one. Now you multiply in two binomials. Two polynomials have two terms. So for this, it's also kind of like a distribution, but you have to basically multiply everything by everything. So the best way is to be systematic about it. Start on this parentheses and take x squared and distribute it over here. So you're going to multiply x squared by that and x squared by that. So I'm distributing the x squared. And then you have to do it for the other term in that parenthesis. So you also have to distribute the 2. You distribute the 2, you have to multiply that by that and that by that. Alright, so now let's write down what those are. First, starting with that one, distributing the x squared. So x squared times 3x squared, that would be 3x to the 4. X squared times negative 7, that would be negative 7x squared. Now let's do the bottom arrows. 2 times 3x squared, that would be 6x squared plus positive, both are positive. And then positive 2 times negative 7, that would be negative 14. And then you should take a look and see if there's any terms that you can collect to simplify. And these two are like terms. And we collect them. So negative 7 and positive 6. Negative 7 and positive 6 has negative 1. Negative 1. So this is going to be 3x to the 4th minus x squared minus 14. Alright, and that's it. Okay. Alright, now let's do the next one. Okay, let's multiply this one. Same thing. Distribute each and every term on the first parentheses over the second parentheses. So we're going to distribute uh, the x first. You have to do it over everything in the second parentheses. So distribute that x times x squared, x times minus x times 1. And then we have to do it for the next term, this one. So 1, negative 1 times negative x times 1. Okay, so you have to do all those arrows. So let's start with the ones on top. X times x squared is x cubed. X times negative x is negative x squared. X times positive 1 is just x. Anything times 1 is just itself. Alright, and now we do the bottom arrow. So this is going to be plus x squared minus x plus 1. Okay, and then now combine like terms. Like terms, let's see, you have that one and that one are like terms, and these two. Okay, x cubed cannot be combined with anything, so it just carries over x cubed. And then negative x squared and positive x squared, those two cancel each other, negative 1 and positive 1, that gives you 0, so you don't write it. So there's no x squared term. Then positive x and negative x, again, those cancel each other. 1 and negative 1, that's 0. And then you have the plus 1. So it actually simplifies to this, to x cubed plus 1. Alright, and the very last example on how to multiply polynomials says multiply x plus 4 squared. Okay, for multiplying x plus 4 squared, you have, remember that squaring something means you multiply by itself. Saying x plus 4 squared really means that you have to multiply x plus 4 by itself. So you should write it out twice. That's what that means. You multiply an x plus 4 by itself, and you have to FOIL this. You have to do this, what we just did here. Right, so this is going to be x times x times 4, 4 times x, and 4 times 4. So starting with the top arrows, x times x is x squared, x times 4 is 4x. Now doing the bottom arrows, 4 times x is 4x, and 4 times 4 is 16. And then you can combine these two, and that gives you x squared plus 8x plus 16. And that's the answer for that. So don't make the mistake, remember that the mistake called the freshman's dream. Don't make that mistake. You cannot distribute that square because there's a plus in the middle. Remember, you can only distribute squares when everything is being multiplied. So you cannot say that this is x squared plus 4 squared. That is absolutely wrong. That is the freshman's dream mistake. You cannot do that. So you have to write it out twice and then do the foiling thing, the multiply everything out. So unless you know the actually formula that is a shortcut, that's what you have to do. There's no other way of doing this. The only other way is to memorize the shortcut formula. And the shortcut formula is this formula that I wrote right here. So let me take a moment to explain it. I really like this formula. I never really do this. It's the correct way of doing this. It's just time consuming. I think in college algebra and in math in general, you square a lot of things, and it is so much quicker to apply that formula and get the answer real quick, and you don't have to do no foiling thing. So here's what the formula says. If you're going to square something that has two terms like this one, So let me start by doing the plus version first. Um, the minus version is really the same thing. Okay, so you have to square the first one, and you're going to square the second one. So a squared plus b squared. But there is always a term in the middle, and because there's got to be three terms. The term in the middle is going to be the product of these two doubled or times two. So you multiply the a and the b. A times b is ab, and then times 2 is 2ab. So it's going to be 2ab. And that's it. Alright, for the next one, it's going to be the same. Square the first one, square the second one. If you square negative b, you're going to get positive, so that's why that's going to be positive regardless. So in both cases, you're going to get plus b squared. And then the term in the middle, exactly the same thing. You multiply a times negative b, that's negative ab, times 2 is negative 2ab. So these two formulas are usually abbreviated uh, by writing a plus or minus whatever this is squared equals a squared plus b squared. These two never change, and the one in the middle is plus or minus ab, depending on how you start. If you started with a plus, that's going to be a plus. If you started with a minus, that's going to be a minus. But this is very convenient. Let me do a couple of examples how to use this. Very convenient. So I really recommend that you memorize that shortcut formula. So let's apply it to this thing. So x plus 4 squared, according to this formula, would be square the first, square the second one, and there's a term in the middle that is always multiply these two, so 4 times x, that's 4x, and then you double that, times 2. So 4x times 2 is 8x. And that's it. We'll now write 16 instead of 4 squared. And that's all. Really simple. Let's do another one, two more. Let's say uh, square x plus 6. Okay, square the first one using the shortcut. Square the second one. And instead of writing 6 squared now, I'm just going to write what it is. 6 squared is 36. 36. And then there's always a term in the middle, which is multiply these two. Oops, sorry. Multiply these two. 6 times x is 6x, and double that. 6x doubled, 4 times 2 is 12x. And that's it. Much, much faster. And one more. Let's say I'm going to multiply 3x plus 5 by itself. Square it. 3x plus 5 squared. Okay, you're going to square the first one. Square 3x. When you square 3x, that would be 9x squared. 3x squared is 9 x squared. Square the second one, 25. 5 squared is 25. And then there's a term in the middle, which is multiply these two. So 3x times 5, that's 15x. And 15x doubled, or times 2. 15x times 2 is 30x. So plus 30x. And that's it. That's how you square something really quick using the shortcut formula instead of writing it out twice and foiling and simplifying. Here it just gives you everything, uh, the answer right away, even simplified. So much quicker. Highly recommended.